Something else I wanted to say is, as we go through the review, I go too fast, or you need further explanation on something, have a way of like noting it in your notebook somewhere, whatever, where you need to ask me about number 23, horizontal asymptotes, or, didn't get that on my calculator, need to ask her about that. Like, whatever it may be, I'm building in time at the end of each class, like a good 5-10 minutes, where if someone needs some one-on-one help on anything I went over, I can come over and help you. Okay? That is, as long as you're engaged during the class period. I need to see that it's working. But then I can help you if there's something I went too fast over or whatever. Okay, so we have this function here, this polynomial, and what we want to do is find the image of the graph of f after a vertical dilation of the graph by a factor of 3. Okay, so we are going to come up with an equation where we stretch all these points by a factor of 3 vertically. That's your a value, the number in front. So super, super easy. All we're going to do is multiply the entire function by 3. So literally, it's just the distributive property. But multiplying the whole equation by 3. If it had said like a horizontal dilation, there'd be some factoring involved, completing the square. You're not going to have that. We didn't even cover it this year. So if they ask something like that, I think we've seen a couple questions about like what A does to the equation, and they called it B in the parentheses and C over at the end, H and K we've called it. Knowing where numbers are in a function, what it does to the graph. So that number in the front is a vertical dilation, and it does affect all these points. It will stretch them all by 3. Okay? 24 is a question that you did not learn when you took the mock exam. So chances are you didn't get it right, but maybe you did a good job guessing. We are given rectangular coordinates, and we have to find polar coordinates. There's 2 formulas you have to know to be able to do that. One of them is like our little modified Pythagorean theorem. It's still just plain old Pythagorean theorem, but it is just using the letters that we're using. And then tan of theta equals y over x, sine over cosine, y over x. So to find r and theta, we can plug in what was given, which is our x and y. And it's not required that you draw this graph. I'm just going to draw it to make sure you guys are clear on where I am. This point would be in quadrant 2, because I would go left 5, up 5 to get to that. So we're in quadrant 2, and that will be important in this part of the problem. But here we're just doing 2 legs of a triangle to find the missing hypotenuse. Okay, so that's just 5 squared plus negative 5 squared equals r squared. R squared would equal 50. And when you do the square root of 50, you can simplify that to 25 times 2. Remember, there's no calculator on this. It's not like you're going to get a decimal. You have to be able to simplify a radical. So we would get 5 square roots of 2. Okay, so again, this is happening a lot where we can eliminate 2 answers by knowing part of the problem. Over here, again, time-saving stuff. I mean, I'm showing a lot of work here because I'm teaching it, but do you have to write that step? Do you have to even go to this step? I mean, I'm hoping you can kind of say in your head, what is 5 divided by, I mean, especially with that kind of math, that's simple math. And remember, I'm just always trying to find places to save you some seconds so you can use them somewhere else. And according to our tan tricks, we know our denominator would be 4. But that's not a real mystery, right? You use your multiple choices. There's no way you're going to choose a 6 or a 3 denominator because they don't even offer you those. They're offering us 3 pi over 4 or negative pi over 4. Negative pi over 4 is in quadrant 4, right, going backwards. And our point is in quadrant 2. So luckily, they gave us that. which is quadrant 2, angle 4. 25 and 26 are two very similar problems, and I have a feeling it's going to be something we see. Like, this is all, is the word conjecture, it's all a guessing game, an educated guess on what they're going to ask you about. I do think there's going to be a lot from Unit 1, all the function stuff, mins and maxes and intersections. We're already seeing a lot of that, and we'll kind of evaluate when we're done with all of our reviews what we saw a lot of, review what we think for sure is going to be on there. And one of those things, though, is what 25 and 26 are about, and that is looking at a table of values and being able to determine what type of function it is. There's usually just four, well, there is just four that they would give us, okay? And that is linear, quadratic, exponential, or log, okay? So within these two problems, I'll cover all four of them just to make sure we know. But I would say these are really important. So what we want to do first is say, okay, that's what they want us to do. And we're going to look at the following claim and explanation statements that best fit the data. So I know by looking, always scan these. Don't try and start doing stuff without knowing what they're asking us or what they're offering us as options. And if I look at all four of these, I see we're either modeling an exponential function or a log function. Okay, that has to do with figuring out what's happening in this chart. 3 of the 4 situations I just gave you, linear, quadratic, and exponential, all have to do with the f of x's, or outputs, y values, changing a certain way. Log is the only one that we look at the x values. So when you look at this table, you should say, okay, something exciting is happening over in the x's. They're changing by some number here. But this is just going up by 1. Just seeing that, we should know this is representing a log, okay? And so just by knowing that, not doing any work, you're at a 50-50 chance, okay? Let me tell you when it's exponential. This same table flipped, where this is happening in the f of x column would be an exponential. And on the next one, we'll talk about the other two, which is linear and quadratic. What happens in a log or an exponential function, whether it's in the x's or the y's, is we're multiplying by something, some number, as we go through the chart. If numbers are getting bigger, we're multiplying by a whole number. In this case, we can see it's a 3 that we're multiplying by. If the numbers were getting smaller, it would be like 1/3 or 1/2, okay? But how did I get these numbers? Well, I think we all know what times 5 gives us 15, and then you could kind of check the other ones. But if you couldn't tell, remember, you can go in reverse and divide, okay? So if you were really struggling to figure this out, you could say, oh, 15 divided by 5, that's 3, okay? 45 divided by 15, that's 3. Okay, so if I'm dividing in that direction, I'm multiplying going down. So again, if this happened over here, we would call it an exponential. So if I just flip this XY chart, it's now exponential, okay? And the word we use to describe what's happening here is proportional. And so let's look at our different choices here. Okay, so the sentences are the same up to logarithmic function. Okay, so let's look at this one. Because the inputs, there it is, the inputs over consecutive equal length output value intervals are proportional, or the outputs, okay? This, when it's the inputs, that's log. When it's the outputs, that's exponential. This is a log. This is called proportional. When you're multiplying by something. When we add by something, it's differences. We'll talk about that in the next example. Okay? So in this table, same type of question. Let's see what they're offering us. They're offering us linear or quadratic. Okay? And looking at this table, without even knowing that, nothing's happening exciting with the x's, right? They're changing by 1, which is important. It's consecutive. I mean, it's consistent or constant. It's not like 0, 1, -8, 10, 7. These should always be probably the same number up by 1. So you know it's not a log, okay, because nothing's happening over here. That's the only time we look at the x's is logs. So we know it's going to be linear quadratic, and how do we figure that out? Well, as you go through the table, you want to see what am I adding as I go from here to here, and here to here, and here to here. Common differences is what it's called. Why is it called differences? Well, a couple different reasons, but we can test it or figure it out by going in reverse, right? I can subtract going in reverse to see what I'm adding in this direction, or count on your fingers, or whatever. But I'm doing 85 minus 64, and I get 21. I'm doing 102 minus 85, and for time's sake, I'm just going to grab those answers. 17, yeah, you get 13, you get 9. Okay, so I'm just subtracting. And you'd have to do all of them, because by the time you get to the second one and you notice they're different, you have to have these other numbers. We need to know what's happening here. These are called your first differences. The first time you did your subtractions, okay? Those are first differences. If those are the same or constant, this would be linear, because all that would be is a slope. These are actually the slopes up between the 2 points. Why didn't we do the whole formula? Well, look, the denominator, your second x minus your first x, second x minus your first x, second x minus your first x, and so on, is just going to be 1. So the denominator is 1 in all these slope formulas. So you're really just doing second y minus the first y, second y minus first y. So if these are all the same, it's linear. Because remember, on a line, no matter what 2 points you choose, any 2 points, the slope is the same every time. Okay? Well, it's not linear. So right now you've got a 50-50 chance, right, of determining which type it is. So now let's see what happens next. So 21 minus 17 is, no, that's not what I want to say. 17, what am I adding when I'm going here? So these numbers are getting smaller, so I'm adding a negative number, right? It's not asking for that number. Really what you want to make sure of is that you have the same thing, but I'm subtracting 4 as I go through, right? It's like 17 minus 21, which you can't really write it like that. You have to write it like this, and then just know your answer is negative, because it's what am I adding as we go through? I'm adding a negative 4. Numbers are getting smaller. Anyway, since these second differences are all constant, this is a quadratic. And we did go further than this back in Unit 1. We found third differences. That would have been a cubic. Fourth differences are the same. That would be a quartic, and then a quintic, and so on. But we're not going to go any further than that. So you want to know linear, quadratic, log, and then if that same thing was happening over here, it'd be exponential. Now, let's look at our choices. Because this is really, really important, okay? This came up, I took a week-long training last summer in preparation for teaching this class. I attend monthly meetings about teaching this class. In all these groups, I watch all kinds of videos. I work really, really hard because I want to be the best teacher I can be. And there are several things that pop up throughout this whole year that is being really emphasized. And what I'm about to tell you is huge. We're going to see it on the FRQ. One of our FRQs had it. I know it's going to be on a certain FRQ. We'll get to that next week. You're going to have to know this. Okay, let me tell you what it is. We already know it's not linear, right? So it can't be those two. We know it's quadratic, so 50-50. But listen to how similar these statements are. So close. Okay, so quadratic function, comma. Listen to this one. Because the rate of change over consecutive equal length input values is constant. Okay? Listen to the next one. Because the change in the average rate of changes over consecutive equal length input value intervals is constant. So one says the rate of change is constant, and one says the change in the average rate of change. Which one do you think it is? D. Well, I guess we know the answer. You have the key. But I'm hoping you notice, if it's just the rate of change is different, okay, or is constant, sorry, that's a line, just one. But we had to do a second. The change in the rates of change. Change in the rates of change is constant. That wording right there the change in the average rates of change over consecutive equal length input values is constant is going to be a sentence we are going to want to know. Because in our FRQ that we get to next week, when we have to explain something, we have to put it in our own words, it was really emphasized to the teachers that the graders are going to want to hear something very close to that. You want to kind of put some of those keywords in there. So we'll come back to that idea when we get to the FRQ, but pointing it out to you now also. All right. All right. 2 more of these. One thing to note, if you happen to go on the key to this packet on Canvas, currently this problem is a different problem. I don't know why. My problem is different than yours. It's like distance from the origin. So that's what that's the problem I worked out, the problem I uploaded. Your 27 is different. So just so you know, I'm going to do it here, but the key has a different problem. I don't know why. One of those mysteries in this course. Okay, so let f of x equal this, let g of x equal that. So we have 2 different functions. And what we want to know is what are the x coordinates of the points of intersection of the graph. Okay? And we had a problem just like this yesterday, where we talked about if you want to find the intersection on a graphing calculator, we've done that a million times. We'll practice it. I think it comes up tomorrow, doing it in our calculator. But when you're doing it by hand, what you're going to do is set your functions equal to each other. Because remember, where 2 lines intersect, they share the same point. They share a point. They have a point that is equal. So where the 2 points intersect, they have the same x, they have the same y. Well, they want to know the x, so we're just going to set them equal to each other and solve. And we had one similar to this yesterday. But I see I've got sine and cosine in the same problem. I want to put everybody on one side together, so I'm going to subtract cosine from both sides. And we really don't want to have 2 different trig functions in the same equation, but we can take care of that by factoring out the GCF. So here's factoring using words. We have a binomial here where cosine is the GCF, and whatever's left over goes in the parentheses. And by doing that, by factoring that, our 2 factors separately have the 2 different trig functions, which is perfectly legal. We can just set each of those equal to 0 separately and solve them as 2 separate little equations here. So, using our unit circle, we want to know where is cosine 0, okay? That sounds like a quadrantal to me. Again, for the millionth time in this course, I'm advising you to be super careful with the quadrantals. Those zeros and ones just kind of get muddled in my head, maybe your head, and so drawing this is always super helpful. Cosine is 0 up at the top and down at the bottom. And then over here, I would add 1, divide by 2 to get the trig function by itself. And sine is going to be 1/2 at all my denominators of 6, right? Square root of 3 over 2 here, 1/2 here. Use all your tricks. Sine is positive 1/2. Sine is positive in quadrants 1 and 2. So that would be B. Okay. Last one of this packet. Rational function is given. They want to know which one of these is true. So remember, rational functions have so much going on. A rational function is a poly on top and a poly on the bottom. And there's usually factoring involved, and then we find zeros, and we find VAs and holes, and they make really funky graphs. But so there's a lot we can talk about with rational functions. But again, start here. What do they want to know about? Don't just start factoring. You don't have to factor this problem, okay? You're tempted maybe, because you really want to factor, you miss it. but you don't need to. So it's all four of these are talking about slant asymptote, horizontal asymptote, or no horizontal asymptote. So those questions come down to the degree of your numerator versus the degree of your denominator. So we learned the three different situations. This one is where the numerator's degree is greater than the denominator's degree. Whenever that happens, we have no horizontal asymptote. Okay? But be careful. So let me back up. We can get rid of these two because these are saying that there is one, and we know there is no horizontal asymptote. But is there no horizontal asymptote? That's true, but we could possibly have a slant asymptote. And slant asymptotes exist when the numerator is one more, just one more than the denominator. So if I subtract these two numbers and I get 1, there is a slant asymptote. Because in the same situation, let me just show you. Like if my numerator's degree was 5 and my denominator's degree was 2, that would be no HA. And it would have no SA. No SA. Because it's not a difference of 1, right? It has to be a difference of 1 to have a slant asymptote. Now, this did not ask for a slant asymptote. It did not ask for what it is. Just does it have it? But if it did ask for it, you have to use polynomial division. We learned 2 different types of division. One was long division. One was synthetic division. And in my key, if you wanted to look at it, she actually found the slant asymptote by doing long division. And if you remember, whether you use long division or synthetic division, you get rid of the remainder. So once you get to this number, you're done. So that is where the slant asymptote would be on the graph. It didn't ask for that, so it doesn't really matter what it is. But I wanted to point out, just since it was here, that the reason she didn't use synthetic division, remember, like if you're dividing by x plus 1, you find the 0 of that and do the backwards like L thing and put all your things, is you can only do synthetic division if your divisor, what you're dividing by, is linear. So since this divisor was quadratic, x a second, you would have had to do long division, okay? So just keeping that in the back of your mind, but try not to do more work than you have to. I have no idea why she did that unless it was just to review long division, okay? Okay. All right. Put your blue packet in your binder and get your pink packet out. I think we're doing 3 problems. 79, 80, 78, 79. Yeah, we're doing a few. We're going up through, I don't even know. I can't talk. Yes, we're doing 3 problems, 76 through 78. Yeah, be really fast. We're in the calculator stuff now. All right. So guys, you want to clear your RAM immediately upon doing every problem, okay? One of the things that you want to remember is that you're always wanting to be in radian mode for the entire exam. You'll never be in degree mode. And by clearing your RAM, that takes care of putting you in radian mode, okay? So we've talked about it many times. Clearing your RAM puts you in rectangular form and gives you radians, okay? So let me read this problem. The table presents values for f at selected values of x. A cubic regression, blah, 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 is used to model these data. What is the value of f of 5 predicted by the cubic function model? Okay, so understand, this is real data, whatever it represents. We don't care really, but just that's what actually happened. What we're asking our calculator to do is take that information and force it into a cubic formula, okay? Think about what I mean by forcing it. And the word regression means it's a model. It's the best possible A, B, C, D we can get given these numbers. And the reason I say like force it and it's a model is because in the real world, your data very rarely, I would say it's less than 1% chance that your data will exactly match a perfect cubic or a perfect quadratic or a perfect line. It's real, so it's not, you might have outliers and things like that, okay, points that don't fit the model. But what we did get is like a line of best fit. That's what a regression is. It fits the data as closely as possible. So one thing I want to get out of the way that I could see a student being confused by is, what is the value of f of 5? Well, isn't it this? It says it right there. 5 is my input, so that's my answer. But it's not. This is what happened actually in real life. Okay, this is raw, real data. And we want to see in the model our calculator comes up with how close we are to that. The difference between those numbers is the residual that we talked about a little bit yesterday, and we'll talk more about. So where do we put this data? We put this data in stat. Okay, stat, enter. Now, when it comes time for the AP exam, I know you guys have taken other AP classes, I'm sure. You may have noticed that your AP teacher for that course is never your proctor. We're not allowed to proctor our own exams. In fact, a math teacher cannot proctor any math AP exam. So I can't proctor like Calculus 1 or statistics, and they can't proctor mine. What I'm getting at is whoever is proctoring my exam, and I'll know soon so I can go talk to them, whoever proctors my exam, I'm going to make sure they know a little about these calculators, like that you're allowed to use them, and this next thing. Even if you had a teacher in there that knows how to use a graphing calculator, you won't. But even if you did, they can't help you. You can't say, I don't know what's going on. They can't help you anyway. So the reason I'm bringing this up is I have seen a problem with the calculators at this step over the years, and I've never figured out why it happens. And what will happen sometimes is you'll only have L1 and the rest are absent, or it'll start with L2. I don't know what makes that happen, and clearing your RAM does not fix it. So I want to just share with you 2 things you can do if this happens. Okay? The first one is to fix it yourself. It's super easy to fix yourself. Okay? Which is go back to your stat, and number 5 says setup editor. If you hit 5 and then enter, it will fix the problem. So I don't know what makes it do that. I don't know why clearing your RAM doesn't do it, but that does. So stat, enter, something's wrong here, go back to stat, hit 5, enter. Are you going to remember that? Who knows? So your second option is I'm also going to make sure, so you guys are going to be given these calculators. Don't worry. Sabine, would you agree the buttons are the same, okay? It's just a little fancier. These are the ones we bought for you. These are the ones you're going to be given on exam day. But I'm going to make sure your proctor has a backup of like 10, at least 10 of the battery ones. So if there is something wrong with your calculator and you can't figure it out, remember, they cannot help you. You are going to say, oh, my calculator is dying. Can I get one of the backup ones? Which I'm going to make sure that the proctor knows they're allowed to do that, okay? So in a pinch, get their attention and get a backup calculator, and that one should be okay. What are the chances? All right, so back to this problem. Sorry. So now we're in stat, enter. Guys, take a second and type in the data. 1, 3, 5, and so on. I am notorious for talking and doing this too fast or whatever the reason is and making mistakes and then having to start all over again. Obviously, good advice is to take your time, do a double check that you put all your numbers in right, and then go on from there. So list 1 is your X values, list 2 is your Y values. Make sure you hit enter after the last number in each column so it's entered into the brain. And then we go to stat again, over to calc, and then it told us we want a cubic regression. So we'll go down to number 6. And we do want to store it because we're going to go to the table to see what the model has for us for 5. So you have to tell the calculator, hold on to this information for you. So remember, alpha, trace, enter, enter, enter. And this is the model. There's the A, the B, C, D. We don't care about that. Don't bother writing it down. It doesn't mean anything to us. It didn't ask for the equation. We want to know in the table, go to your table, what is the Y value when X is 5? So you can see that it would be this one right here. Okay? So you can see if I subtracted those a I forget the order at the moment. One, if it's positive, it's overestimated, negative, or whatever it is, but we get our residuals. What we looked at yesterday was a graph, that scatter plot that had a pattern. That should be a graph of all of the residuals. All this subtract. I find this one, I find this one, I find all of them, and I plot the differences between the numbers. That's what that was. You don't want a pattern. Okay. Next one, the rate of people entering a country music store at a large arena is modeled by this. Blah, 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 blah. Based on the model, at what value of t does the rate of people entering the arena change from increasing to decreasing? Guys, changing from increasing to decreasing, what's that called? What is it? Yes, give me another name. What? It's concave down, max, the max value. We want to know where it changes from increasing to decreasing. That's your max, okay? We're going to do it with our calculator. And some people were confused in the last period. It's saying at what value of t. So here we have t and r of t, fancy for x and y. So really, we just want to know the x value of this maximum point, okay? That's what that's saying. So clear RAM, and when we type in an equation, we just go up to y equals. So first period I did this problem 3 or 4 times because I kept typing it in wrong. So I'm going to close my mouth for a minute and type so I don't waste your time. Okay, Michael, Matthew, Michael. We're in the pink packet. You can't sleep through this. You're way behind us here. So I need to find the max of this graph, and I can clearly see it. I'm going to find it here in a second, but I want to tell you something else I saw. It gives us a window of 0 to 5. So when I did this the first time, I was like, I'm going to change my window, which is fine. I changed my window to 0 to 5, and it's just really zooming in on that part. So you can see my graph looks a little different because I'm super close to that like top part. And this is really spread out, but I can still put my left and right bound like here and here. Remember, it doesn't have to be right up against it. I can see it happen somewhere up there. It's not as easy to see as the other way, and it works totally fine. So if you saw that and you changed your window, that's fine. And that would be required if in my default window, which is what it does just naturally, if this was like a quartic where it goes up, down, like there's more than one highest point, you want to zero in on the window they're saying. That's when you would definitely want to do it, okay? But here, there's clearly one maximum in between these, first 5 points. All right, so how we find our max, we go second calc. Remember, this is where you do min, max, intersection, zeros. So we want number 4, which is max. And we just use our left and right cursor. Just get somewhere on the left side of that maximum, enter. Get over to the right side somewhere, enter. It asks us, do you want me to guess? Yes, please. And then we'll take the x value. Okay, so that's 3 point blah, blah, blah. This is the last one. We went really fast. This one is a little confusing, but it's our last problem. So everybody stay with me and pay attention to this problem, okay? And then you'll have the rest of the time if you have other questions or whatever you want to do. All right, so in this problem, we're talking about a geometric sequence, and they give us the 5th term, they give us the 8th term, and they want the 12th term, okay? So we wrote the formula. I left something off of there. Anyway, we talked about this formula yesterday, which was G sub n, and I think I wrote it with A sub 1 here. You can put A sub 1, you can put G sub 1. I'm just going to put A sub 1 since that's what I tend to always write. That doesn't really matter. When we look at this formula, we should know that this represents the first term, right? Whether you call it G sub 1 or A sub 1, it doesn't matter, the first term. And this one right here, we talked about this yesterday, this one right here matches this one right here, right? So if I put the fourth term in, this 1 would change to a 4. The 10th term in, this 1 would change to a 10, okay? I think we've got that. Let's take it a step further. G sub n is the one we're trying to find. Well, in this problem, I'm going to need R. I need R to be able to find the 12th term. I have something to plug in here. Which I know that number, and I want the 12th term, so I have that number, but I need an R to be able to plug in. How do I find R if I don't have consecutive numbers? Remember the graph yesterday? It had a whole bunch of points, and we took the second ordered pair, the third ordered pair, and we could just do division in reverse to figure out our R. We have 2 points that are far from each other. They're not consecutive. So I can't just do like 60.75 divided by 18. It won't work. So what I'm going to do is plug these 2 points into this equation and solve for R. So I'm going to call one of these A sub 1. It's actually this one. And I'll tell you why in a minute. I'm going to call you A sub 1. I'm going to call this guy G sub n. Because watch, this is confusing. This G sub n, this number matches this number, right? If I'm looking for the 12th term, I'm looking for G sub 12, I put a 12 right here. But I could plug something else in here and match that number to it. So I'm going to take 18, plug it in for this right here, equals my first term, which is 60.75. I don't know the R. And then N is the Is it 5? I don't think I meant to do that. Yeah, I did. Okay, I did mean to do that. 5 minus 8. There's a reason I paused, okay? I keep doing the same exact problem this way, and when I get to this step, I'm like, ugh, and it works. You can totally do this problem with a calculator with the way I set it up. What's bad, though, what just makes it a little more complicated, is you're going to get a negative exponent here. I don't really want a negative exponent. I want a positive exponent. So you could have switched these. I could have called this the first term and this the G sub n term. It doesn't matter. As long as you plug it into the calculator correctly, that's fine. For time's sake, and I like that I did it this way, because when you see that, you might go, I don't want to do that. All you have to do is flip those and flip those. So if I make this 60.75 and this 18, that just flips these numbers. And if anybody wants to go back and put that in their calculator, you totally could have done it. It's just having to deal with a negative exponent is not as easy. Okay, but it would work. You would get the right answer. But let's try to make life easier. So without really overthinking it, I plug one in for one, the other one in for the other. Let's just flip them. So if I flip those, I have to flip those. Okay? And now let's solve for R. So I'm going to get R by itself. I'm going to make that a 3. This is going to be divided by 18. I don't know what I'm going to get when I do that. I know I have to do more work to it, so I'm just going to leave it as a fraction. And I want to get R by itself, so I'm going to do the cube root of both sides. Let's remember where our cube root is. It's in math. So math and number 4. Number 4, math 4. And I get an R value of 1.5. That is what we need. Now we can plug right into the original equation. You can pick whatever one you want for this right here. You can use the 5th term, you can use the 8th term. It doesn't matter, okay? It does not matter. both of them are smaller than 12, so you're going to have 12 minus 5 or 12 minus 8, so it really doesn't matter. Pick whichever one you want. So to find the 12th term, I'll just use 18, so it's sitting right there. 18 times r to the n is 12, right? These numbers will always match, minus, and the 18th term is, number 18, sorry, is the 5th term. So put it in your calculator. You should get 307.547. Okay. That's where I'm going to stop today. We have a good amount of time till the bell rings, so, ask for help